Hi guys, in this video I'm going to show you how to apply graph transformations to trig graphs. Hopefully you're familiar with the notation for transforming graphs. However, if you're not, please do have a look at my other videos on transforming graphs. What I'll do is I'll put a link in the little description bit below so you've got easy access to those. So, the first graph that I am going to look at transforming today is y equals 2 sine x. Now if we take y equals sine x as our f of x, what we've got here is y equals 2 lots of f of x. So 2 f of x. So with that notation, we know that this means I'm going to have to multiply my y values by 2. So if I just look quickly at y equals sine x, that's my general y equals sine x graph. And here I've got 360, here I've got 180, 90, 270. My maximum is at 1, my minimum at -1. So when I multiply my y values by 2, 0 is going to stay 0. 1 will actually become 2, 0 stays as 0, -1 becomes -2, and 0 stays as 0. So my sketch is going to look like this. My x values, my maximum x value stays as 90, this point here stays as 180, my minimum point x value stays as 270, and this point here stays as 360. I needed to multiply my y values by 2, so 1 now becomes 2, and -1 now becomes -2. So the next one that I'm going to look at is y equals cos x plus 30. So if I say y equals cos of x is my f of x graph, what I've got here is y equals f of x plus 30. So what does this mean? It's a translation in the x direction. And what I'm going to do is I'm going to end up moving left by 30 degrees. Well, it's 30 degrees because I'm working with trig functions. So what I'm going to have to do here is subtract 30 from the x values. Looking at my basic cos graph, looks like this, where this is 90, 180 in the middle, 270 and then 360, maximum at 1 and minimum at -1. So drawing my graph, this point here is actually going to move left by 30 degrees because the x value at the moment is 0. So subtract 30 from that is actually going to become slightly left of my y-axis, -30. This point here will become 60. My minimum will be at -150. The point here where it crosses the x-axis will be at 240. And this maximum point here will be at 330. So I am going to have so between 360 and 0, so here's 0 and here's 360, that's 360, that point there is 330, this point here is 240, this point here is at 150, this point here is at 90. My minimum stays at -1. And my maximum stays at 1. just to remind you, oh sorry, this isn't 90, this is 60. I needed to subtract the 30 from that, sorry. So that should be 60 because I've taken 30 off of the 90. I do apologise for that. Hopefully you can see that that is 60 because it would have been 90 and I've had to subtract 30. Okay, my next graph for you, I'm going to look at y equals tan x minus 90. So I do have another horizontal translation, and this time it will be moving right because this is negative. It will be moving right by 90 degrees. So I'm going to have to add 90 to my x values. Now, looking at my basic tan graph, which looks like that, where this is 180, 360, asymptotes at 90 and 270. So adding 90, that means that this point here is actually going to move to here, and everything is going to move on by 90 degrees. So slightly wonky, sorry. So this point here is going to come up like this. It's actually going to continue down like that. So this point here is 90 degrees. My asymptote, which would have been at 90 degrees, is now at 180 degrees. This point here, which would have finished at 180 degrees, will actually finish at 270 degrees, and it will continue up in this shape where the asymptote, which would have been at 270 degrees, is now at 360. Okay, so there's 3 examples, one for each trig function. So the next one I've got for you is y equals sine x plus 3. So if I've got y equals sine x as my f of x, then this must be y equals f of x plus 3. So what I'm going to have to do is to add 3 to the y values. So my graph is actually going to move up by 3. My basic sine graph looks like this, where this is 1 and that's minus 1. So my minimum point now, by adding 3 to that negative 1, means it's going to now be at 2. And my maximum point, which would have been at 1, goes up by 3. So the maximum y value, the y value for the maximum point will be at 3. So this point here is 0, and because it's moved up by 3, that point there must be 3. My maximum is at 4, my minimum is at 2. Put on my x values, which would be the same. Because I haven't altered my x values from the original graph, I've only added 3 to my y values because of this transformation. Okay. Y equals cos of x minus 10. Again, another horizontal translation. So what I'm going to do is I'm going to add 10 to my x values. Therefore, because I'm adding 10 to my x values, it's a translation to the right. My standard cos graph is going to look, or looks like this, and maximum starts at 1 and minimum at -1, 90, 270, 360, 80. You will get used to these graphs. The more you use them, the more you plot them, the more you sketch them, you will get used to where all the points are. So I need to add 10 to all of the x values. So I add 10 to 10 and 10 and 10. So this becomes 100, 190, 280, 370. So sketch that. So this point here, where my maximum is now at 10, because this point, sorry, that should be your maximum, should come down like that. So I didn't draw that very well at all. That point now is 10 because this point has moved across by 10. This is 100. This is 190. This is 280. And I haven't quite reached my maximum at 360 just yet. Maximum at 1 and minimum at -1. Next one, y equals 1/3 cos of x. Again, the number is in front of the function, so I'm going to multiply my y values by 1/3, because if my y equals f of x is cos x, I now have y equals 1/3 f of x. So what's going to happen is my standard cos graph, this would have been at 1 and the minimum at -1. When I multiply those by a third, this is going to become a third and this is going to become -1/3. So I'm going to end up with something that looks like this, where this is a third, this is -1/3. Have my x values changed at all? No, therefore this is 90, 180, 270, 360. Okay, 6 down, 6 to go. So my next one is y equals sine of 1/3 x. So very similar to the previous one, however my third is inside the brackets. So if I look at my graph as y equals sine x as my y equals f of x, what I've got here is y equals f of 1/3 x. Hopefully identifying this from your function notation for transforming graphs, you know that this means you are going to multiply the x values by the reciprocal of this, which is 3. So looking at my sine graph, basic sine graph, 360, 180, 90 and 270. So my sketches are getting worse and worse as the video goes on. On my transformed sketch, 0 times 3 is going to stay at 0. 90 times 3 gets me 270. 180 times 3 gets me 540. Now, in my other sketches I've only gone up between 0 and 360, so I'm going to stay with that. So this graph is going to look like this. So just to talk you through what I've done, my maximum, which would have been at 90 and 1, 90 multiplied by 3 gets me 270, so that's why the maximum is all the way over here. 180, which is where the graph comes back down and crosses the x-axis, when we multiply the 180 by 3, that gets 540. Therefore, 360 must be somewhere up here, because it would be 540 by the time it hits the x-axis again. So that is my graph for between 0 and 360 for y equals sine the third x. My next one, y equals cos of 2x. So this time I have got y equals f of 2x. So I'm going to have to multiply my x values by a half. Reciprocal of 2 is 1/2. So looking at my standard cos graph, 90, 180, 270, 360, maximum at 1, minimum at -1. I need to multiply all of these by a half, so 90 will become 45, 180 will become 90, 270 will become 135, 360 will become 180. So to show you what this is going to look like, let's try and make sure it's as straight as I possibly can get it for you. So as I said, we end up with 45, 90, 135 and 180. Now that doesn't reach all the way up to 360 like I've done in my other examples. So what I'm going to do is, we know that this repeats on a standard graph every 360 degrees. Therefore, if there's one repetition of the curve in 180 degrees, we must then have 2 within 360 degrees. Simply being, if I was to draw this out between 360, this point here would be 720. Half of 720 is 360, and therefore you can see that the repetition, oh sorry, that should be 360 there. You can see the repetition of the curve every 360 degrees. When we multiply our x values by a half, the 720 will become 360, and therefore we can add in these values here. This point here is this point here, which when we multiply this by a half, we get 225. We have the minimum point here at 270. We have this point here at 315 degrees, and then that one at 360. My maximum points are at 1, my minimum points are at -1. Okay, something slightly different here. Y equals minus sine of x. So here I have got y equals minus f of x. So I'm going to multiply my y values by -1. So standard sine graph, my y value here, which would be 1, will end up down here, and my y value here, which is -1, will end up here. Now, from our standard graph transformations, hopefully you can identify that this is a reflection in the x-axis, and therefore the graph is going to look like that. The x values haven't changed, so this is going to stay as 180, this is 360, this is 90, this is 270, my maximum at 1 and my minimum at -1. Let's do it for y equals negative cos of x. Exactly the same. I need to multiply my y values by -1. I'm expecting a reflection in the x-axis again to help me visualise it. That's my standard cos graph, and therefore this time it's going to, this point will be here, that's going to stay there, this point will become up here, so I'm going to end up with something that's going to look like that. I'll draw it here properly for you so you can see. So forget that was there, that's my standard cos graph. 1 will become -1. This will become a reflection in the x-axis, so we'll come up here. Maximum point at 1 now, finishing off down here. X values have stayed the same. I really do hope that these explanations are making sense to you. Okay, so let's look and do the full set. Let's have y equals minus tan of x. So we know my tan graph looks like that. I'm going to have a reflection in the x-axis again. I need to multiply my y values by -1 because I have got y equals minus f of x. And so what's going to happen is this point up here will become and look something like this. This will become up here and so will look like this. This point will come up here and we'll have something that looks like that. So just to show you, I've drawn this quite big. Doesn't matter, it's only a sketch. So this point here stays at 0 and this point here, which would project up, is going to project down. My asymptote stays at 90 degrees. This point down here will be reflected up to here and will, where it would naturally come like this, will become like this, with an asymptote remaining at 270 degrees. This point here remaining at 180 degrees. And finally, this down here, which would be down here on a normal tan graph, will be reflected up here and will look like that. Okay, one final one for you. This one involves a combination of two different transformations. So here I have got y equals 2f of x, but inside my brackets I've got the minus 20. So this means I need to multiply my y values by 2, and this means I need to add 20 to the x values because I've got the translation of the 20 degrees being positive because I've got negative here, so I have to add the 20 because this negative means it's going to move to the right. So Here's my standard sine graph, because that's the base of the function that we are working with. This would be 1 and negative 1, 180, 90, 270 and 360. So we know that the maximum and the minimum points are now going to become 2 and negative 2. We also know that we are going to have to add 20 to our x values. So this 0 here will become 20. The maximum point will move to 110, 2, because my y value I've had to multiply by 2, don't forget. 200, 290 and minus 2. And the 360 would become 380. So in my diagram, in my sketch, just the sketch, it does not have to be to proportion, it doesn't have to be measured out, as long as the pieces of information are clear, as you know what you are working for. So this point here was going to become 20. And remember, this would have met at 380 at the x-axis, and therefore it hasn't quite met it at 360 degrees. We do need to make sure that we show, sorry, that should be more, that's it. We know that that's 20. We need to make sure that we're going between 0 and 360, which is why I've had to add on this bit. The reason I know it's going to be like that is because it will come and it will have the curve naturally going like that. So adding on the information that I need to have, I've got 2 as my maximum, minus 2 as my minimum, because I needed to multiply those y values by 2. My maximum is now going to be, it would have been at 90 on the x-axis, but now it's going to be at 110 because I need to add 20 to that. This point here becomes 200 because it would have been 180. Add 20 to that gets me 200. 270, which is my minimum point here, will now be 290 degrees, and we've got that minimum point of negative 2 on there. And finally the 360, as I explained, it doesn't come all the way up to the x-axis, because when I add 20 to that, that becomes 380. Okay, there we go.